let's start with in this unit, before I talk about what the actual unit is about. Want to do a little bit of review of grade 9 algebra. Really the stuff that you need to know in order to be successful in grade 10. Okay. So you have to refresh your memory on certain things like powers and simplifying expressions, solving equations. So we'll do a few of these today and then we'll finish the rest next class. First thing we'll start with powers we talked about last year. What is a power? It represents repeated multiplication. So you're taking some number and multiplying by itself a certain number of times. What does a power look like? Well, it's got a normal size number and then a little number up and to the right. Okay? That bigger number here, so example in this power, is called the base, and the little number is called the exponent. And basically, this means take 5, multiply by itself 3 times. So you would get 5 times 5 times 5. If you evaluated, you'd get 125. And how do we read powers? Well, you can read it different ways. 5 to the 3rd power, 5 to the power of 3, just plain old 5 to the 3rd. If the exponent's at 3, we can use another word, 5 cubed. Okay? So, and the base, remember we talked about last year, could be a positive number, could be a negative number, could have parentheses, might not have, could have fractions. Okay? We talked about all those. All those. Okay, with algebra, there's 2 big things. Taking expressions and making them simpler, as small as possible, and solving equations. We're going to talk about simplifying first. Okay. So, an algebraic expression, you don't have to memorize definitions for these. Okay, but you should be familiar with when I say the word variable, you should know what I'm talking about. If I say the word constant, you should know what I'm talking about. So an algebraic expression is just like a math statement. And it could have numbers in it, variables in it, operation signs in it, like plus and minus, maybe even divide and multiplication, although we never write the multiplication symbol when we're showing multiplying in algebraic expressions. Okay? So algebraic expressions contain terms. What's a term? A term is separated by plus and minus signs. So in this example, 5x squared minus 3, it's got 2 terms, 5x squared and minus 3. There's a variable, a lowercase letter, in the first term, x. There is a constant in the expression. That means it doesn't have a variable attached to it. So this would be an example of a constant, minus 3. And any number that's in front of a variable getting multiplied, we call a coefficient. So the coefficient of this term would be 5, because that's the number in front of the variable. And we can see, too, that these things can also contain exponents as well. So what do we do with these expressions? Well, we evaluate. We find the value of them if you are told the value of the variables. Okay? That's the only way you can find the value. So for this one, you can't do anything with this unless I tell you what x is. You can just, I mean, it's just an expression. Where do we use these things? Every time there's a formula for something. Every formula you do in math, in science, in any other courses where there's formulas. Those are all algebraic expressions. So how do we evaluate? Well, we take our expression, and every time we see a certain variable, we replace it with the number that we're told that it is. So 4, and instead of x, I'm now going to replace that with 4 in parentheses. Minus, and instead of y, I'm going to replace it with -3 in parentheses. And there's nothing more to replace, but there's still a plus 10. So now it's just a matter of calculating. 4 times 4 gives us 16. Minus -3 turns into a plus. There's still a plus there. We add those 3 numbers together. We get 29. So we evaluated it. Some of these expressions can get a little complicated. But if you substitute correctly and you do proper order of operations, you'll be able to handle it. So in this example, I'm given this expression, and I'm told that x is 3 and y is -2. What does this look like when I substitute? Anybody? Yeah. 3 in. What do I have to put around them? Whenever you substitute, what do you always have to put around the value? Yes. Right.
And then in brackets 3.
Yeah. Good. That's right. Now, to calculate it or evaluate it, remember proper order of operations. Think bed mass. So we got to do exponents first. So this has got an exponent in it. It's also got multiplication in it. I do the exponent first. Grab one of each of those. So remembering this from last year, what is -2 in parentheses all squared? -4? Right, because it's -2 times -2 because of those parentheses. So this is going to turn into 3 times 4 minus 2 times what? When I do 3 to the 3rd power? 27. What's that? No, wait. Oh no, because it's bottom of 3. But it'll turn into minus when we do it. So 3 times 4 is 12. 2 times 27 is 54. And then I do 12 subtract 54. Don't worry if you can't do that in your head. Just use a calculator if you need to. Okay. And we get -42. Okay. Sometimes the expressions we get can be simplified. We can make them easier to work with before we evaluate. And one such thing that we did last year was collecting like terms. If a term has the same variables in it, doesn't matter what the numbers in front or the coefficients are, we can put them together. So could somebody tell me an easier way to say this expression? What's an easier way to say 6x minus 2x? 4x.
13y.
plus 13y. Good. That's as far as I can go because I'm not told what x and y are. I was only asked to simplify it. I wasn't asked to evaluate it. I can't tell you to evaluate it unless I've told you what x and y were. Remember, we're adding and subtracting here, so there's no exponent laws yet. Okay? If you combine terms that have exponents, you don't change the exponents. So I've got a couple of x cubes here. I've got a 3x cubed and a 2x cubed. Together make 5x cubed. I've got a minus 8x squared and a plus 9x squared. 1x squared, or just even x squared. Either one is correct. No, that's fine. If you put 1x squared, it's still right. I've got a minus 3x and a minus 6x. Negative 9x, because negative 3 and negative 6 gives us negative. And I've got a plus 3 and a plus 1. 4. And it's plus 4. And again, that's as far as I can go. I can't add these together. Okay? Don't confuse this with doing exponent laws. We can multiply these together, which we'll see in the next section. But you can't add them. You can only add them if they had the same exponents, or subtract them. Speaking of exponent laws, that's another way we can simplify. 3 exponent laws. Okay? When we multiply powers, actually, whenever you do an exponent law, what happens to the base? Stays the same, nothing. Doesn't matter whether it's a variable or a number, it stays the same. When we multiply powers, what do we do with the exponents? Add, yes, that's right. So what is x to the 4th times x to the 5th? To the 9. Don't get thrown by this. Base stays the same. 7 to the 9. Yeah.
Will we just like make it negative?
This one?
Yeah.
Yes.
So it'll be negative, and we still add the quantities.
You still have the exponents, yes. So it's going to be negative. Now multiply the powers of a.
A.
A to the
5th.
Yeah. Multiply the powers of b.
12.
B to the 12. Good. These next two have coefficients in front. Remember, just multiply the coefficients together. These are negative 7 is not the base here. T is. The 4 is attached to the t. Okay? This is attached by multiplication. So negative 7 times negative 3, 21. Now do the t's. T to the 4th times t to the, not 0, 1, gives us, careful, 5. Think of it, you're multiplying 4 t's here by each other, and now you're going to multiply by another t, so you're multiplying 5 t's by each other. This one, just multiply the numbers in front. Remember, they're not exponents, so we don't add them.
So it'll be negative 9 at x, and then 8, and then y, and then 5.
Yep. job. Okay? So that's multiplying. Dividing, oh, sorry, there's one more here. Yeah, this one's a little bit of a more complex one.
Don't you carry it?
Yes. How many multiplications do I have to do? 1?
3.
Remember, when we have something outside several terms, I gotta take this and multiply by every term inside. So I'm gonna multiply those, I'm gonna multiply those, and I'm gonna multiply those. And remember, 5x is the same as 5x to the first. X with an exponent is the same as x to the first. So what is 5x to the first times, well, 1x cubed?
6x squared. I mean, third.
Not 6. 5,
X to the fourth.
5x to the fourth. Remember, you multiply the numbers in front. Only the exponents you add. You don't add the numbers in front. 5x to the first time, times 3. 15x. And 5x, and then you've got a minus. 5x to the first.
5
Yeah,
squared.
yeah,
2.
yeah,
Oh.
that's right. And remember, we can't put these together. We can't add and subtract them into one unless they have the same exponents, and these don't. We can multiply them, but we can't add them. Remember the difference between things like this. Students will often get these two confused. X plus X and X times X. What is X plus X? I've got an X. Think of an X like it's a square or something. I've got another X. 2X. But X times X is when I use the exponent law. X squared. So remember the difference between those two. When you add, exponents don't change. When you multiply, the exponents will change. Second exponent law, dividing. Well, when we multiply, we add the exponents, so it kind of makes sense that if we divide, the opposite of multiplying, what would we do with the exponents? Subtract. Yeah. This first one, base stays the same, x to the first, or just plain old x. Either one is correct. I would accept either one. Next one, be careful.
7 to the fourth.
7 to the fourth. Base stays the same. The base is 7. Here, yeah, Claire?
Okay, wait, I'm on the last one, but wouldn't it be negative 5 to the third?
Yeah,
And then what would the
yeah, good question. Yeah, because basically, anything divided itself is always what? 1. Anything divided itself is always 1. So is this the same as negative y to the third times 1? Well, we don't have to write the times 1, do we? Okay. I mean, you don't go to the store and buy like 4 times 1 pairs of socks. You buy 4. You say 4 times 1 to somebody, they're going to look at you like you're nuts. Okay. Here, we got numbers in front. So remember, divide the numbers in front, then do the exponent law. So 18 divide negative 3,
negative
and now do the exponent law.
6?
M to the third. Because the 18 and -3, they're not bases. They're not exponents. Same idea here, except we got to do a few more, or one more division.
9, 8,
9.
8,
Careful with this one.
6.
Remember, we're dividing.
Oh,
Because this is a to the first, so we do 5 minus 1,
you see the good?
b to the fifth. Good.
Right.
Okay. And finally, because we'll do equations next class, because we've done enough this class. Okay, want to make sure that you get some practice with it. When we raise one power to another, or in other words, power to a power or power of a power, what do we do with the exponents? Multiply 3 more times. And again, the base stays the same. So this would be
8 to 12.
8 to 12. This would be, remember, the base is not a variable, it's 5.
5 to 10.
5 to the 10. These ones you gotta watch out for. Because this is not an exponent. So we wouldn't go 3 times 3. We go 3 to the third. This is the same as 3 to the third times p to the fifth to the third.
Wow.
Because we have to take everything inside and multiply it by itself 3 times. And then multiply those together. So 3 to the third, 27. Now use your exponent law. P to the 15. Yeah, these ones you always got to watch out for. Common mistakes students will make is they'll forget to do anything to the 3, or they'll do 3 times 3, which is not correct. Here, -4 in parentheses, I got to square that. I got to take the x to the 6th and square that. And I got to take the y, or y to the 1st, and square that. So what is -4 in parentheses, that's important, squared? +16.
To the 12.
X to the 12th,
1 to the 7.
y to the 7th. Okay. We'll stop there because I want you to get a little practice with it.